anyone who's looking for a custom antenna solution, Radiantum has vast experience across tons of applications. Hey, it's Eamon from IP Exchange, and we're here with another IP Experience, this time with Mikko from Radiantum, who are a company that does custom antenna designs and also EMC and EMI consulting. Is that correct?
Yeah, that's correct. Nice to be here.
Cool. So just before we get started on what Radiantum does, just tell our audience a little bit about what you do there, and maybe also a little bit about how long the company's been around.
Yeah, sure. So yeah, my name is Mikko Parkkila. I'm one of the founders of Radiantum. Now I'm the Chief Marketing Officer. We started Radiantum 2015, so it has been now a few years already. The background of the company is that we founders, we were working at Nokia, then at Microsoft for a while. And we got the experience and the opportunity to really learn how to design antennas in big corporation. So we had all the tools available. We knew how to use them. We knew how to make the design process as efficient and quick as possible. And then, we started to see what next and realized that there are so many other companies developing electronics that do not have the luxury of our experience and therefore do not have the potential to make it so good wireless devices as the big corporations can. And the idea came that maybe we could help them.
Cool. So in terms of Radiantum's approach to antenna design, because you guys just do the design part of it rather than the manufacturing. That's correct, right?
Yeah, that's correct. So we provide the consultants, design engineers, test engineers. So we have the labs, we do a lot of simulation, but we don't do the manufacturing. So in terms of manufacturing, what we can do still is prototypes, but then it's our customer who then manages the volume production, or then we can introduce one of our partners, an antenna manufacturer, who can then provide those for our customers.
So I guess if you're just doing the design, does that mean anyone coming to you, there isn't a minimum order quantity? It's literally they're paying for your service to design it, and then it's their manufacturing that determines. Okay, that's very good to know. So I did have a look at your website, and I saw that you cover a huge range
that's
of
one
applications.
Of the things that makes us, So that's one of the things that make us different in the market, that we can really provide services to any company, regardless of the size and regardless of the product.
Cool. I went around your website for a bit, and I've noticed that you cover a huge range of different industries for antenna design. But I thought one thing that we've never really talked about on IP Exchange is automotive antenna design. So can you give me a bit of a background on some of the challenges in that environment, and what are the typical protocols that you have to be designing for in an automotive setting?
Yep. So one of the things in automotive that is, let's say, different compared to other industries is the pace of the development. There are very strict timelines, but they are very long process overall.
Okay.
You need to make a lot of double checking. It's really, let's say, sensitive in all of the testing areas, and at the same time they are very, very complex. Because in antennas you do need to consider not just the electronics, but the mechanics around the electronics and where the device is actually placed. So in automotive, quite quickly we need to consider the entire car, how the antennas or devices are placed in a car, and what's the effect on the system in a sense. We are not really system engineers, but we do need to take that into account in terms of the antenna design itself. Then regarding the technologies, so there are typical GPS, of course, LTE, Wi-Fi, these kind of technologies, but then also vehicle to X, ultra wideband, quite many different technologies, that pretty much anything you can think of. And there are a lot of stuff, of course, that are let's say thought about whether or not they could come to the cars. And another sector that is very much driven by the automotive industry is then radars. So
Okay,
many
yeah.
different kind of radar antennas.
Oh, so you don't just do communication antennas, you do like sensing antennas as well in that regard, I guess, if it's for radar as well.
Yes. So how we think about the, let's say, technologies and collaboration with our customers is that we want to be the partner they can rely on no matter what is the product they develop next. And therefore, no matter what the antenna needs are. So we cover anything from, let's say, NFC to then 80 gigahertz automotive radars.
Cool. So I noticed there's a picture of an anechoic chamber in the background of your shot. Out of curiosity, in an automotive setting, do you have to get the whole car in there when you're testing? And is that something that Radiantum does themselves?
Yeah, so when there's a need to test the entire car, unfortunately, our chamber is not big enough. So then we need to use a partner for that. But there are a lot of testing that needs to happen before that. And when we are talking about the modular devices that go into a car, that's something we can measure in our chamber as well.
Cool.
So yeah, technology-wise as well, we can cover quite a lot. But from time to time, there is a specific technology that we don't cover, and then we have partners that we can then use to get those tested as well.
Excellent. So we talked a bit about automotive antennas. Should we talk about automotive EMC as well? Is that a good topic to go into?
Yeah. So maybe in general on EMC. So that's something that we have started as Radiantum a few years ago. We actually bought another company where we got the skill set in. They had a similar background as we did, but instead of antennas, they were focusing on the EMC and EMI. And on that front, we are focused on the debugging.
Okay.
So the EMC, let's say, behaviors or phenomena, they are electromagnetic in nature, so they are actually very close to the antenna behaviors and physics. So it was a quite easy jump, and we faced quite a lot situations where our customers had LTE device going to US market, or then a GPS in their devices. And in case of LTE, problem was that the electronics were generating noise that was starting to desense the reception. And when they were trying to reach the AT&T requirements, they actually failed the sensitivity part.
Okay.
And then they asked us to help because they thought it's an antenna problem, but actually it was on the electronics. And therefore it became like this kind of a natural transition for us to go into the EMC space as well. And GPS, exactly the same problem, except it's not any kind of operator requirement, but the actual functionality of the device to get the position fix.
Cool. So that actually brings up an interesting point, which is when it comes to antenna design for something like a vehicle, because that's expected to go around the globe, what kind of challenges do you encounter when you have to switch between the different bands that are covered around the world? Or is that not such a problem in a vehicle because of the bands used?
So it is something that needs to be considered in terms of the antenna. So certain areas have certain bands, but then maybe even more importantly, you need to consider the certification side of things. So if you select, let's say, one example in my head is now wireless charging, for example.
yeah.
So you have certain frequencies you can select, but then depending on selection, you might not be able to use it everywhere. And once you do it for one frequency, you might not be able to adapt it to other frequencies. So it's actually very important in the beginning to understand which market you are targeting, or any of them, and which those are, and get to know what are the requirements on each of them, so that when you do the actual design, it can then go into all of those markets with either no or minimal changes.
Okay.
So in terms of antennas, it's quite typical that you, for example, have one antenna structure that can handle all the frequency ranges used in the target markets. But then, for example, the radio module you're using only supports certain
Oh, okay. Yeah, I get it.
markets. And because of that, you have already different layout variant or assembly variant of the device due to changing the radio module per region. And therefore, you can also do the tuning of the antenna differently to optimize it for different regions. But then again, there are possibilities to make really global antennas as well. It just takes more time to develop, and potentially more complex, let's say, matching or active tuning, for example.
So this brings me on a completely different note of antennas. This brings me to a question that I wanted to ask after looking at your website, which is, so many devices kind of have many Bluetooth devices, have like inbuilt antennas within the module, but you can also have external antennas. What are some of the advantages of external Bluetooth antennas? And what applications really see that advantage come to light?
Yep. So when the antenna is integrated into the module itself, there's only essentially two things you can do to affect the performance. You need to follow the guideline of the module vendor to place it exactly right way on your main PCB. And then you need to make sure that the mechanics around it, or possibly other components, don't affect it. But you cannot do anything to the antenna itself.
Yeah.
So it's a viable solution as long as you can follow those rules. And that means that you cannot have creative form factors for your device, for example, which would violate those guidelines.
Okay.
So that kind of drives you then to the domain of using some other kind of antenna beside the one that is integrated in the module itself.
Cool. What kind of I guess it could be anything, but can you give an example of some of the end products that you might see requiring the use of external Bluetooth antenna?
Yeah. So let's say all kind of wearable devices, typically. So
okay, yeah, that makes sense.
There are very few modules that have integrated antenna in them that would be suitable for wearable form factor. But then asset trackers that are placed next to metals, they also require a special kind of antenna stem. There are a few modules that also have suitable antenna types, but it gets very tricky to even make them work on this kind of environment where you place metal very close to the PCB. But there are tricks to be done. And then I would say in all of these use cases, you have the possibility to kind of play with the expectation. So if it's enough to just make a connection short range with Bluetooth, you can tolerate less optimal antenna. But if you're interested to maximize your power consumption, for example, then you want to have as good antenna as possible with many technologies. So then you might want to drive for the optimal performance.
Okay. So obviously you guys are designing antennas all of the time. Are there any particular antenna well, I suppose this is a kind of an interesting question because you don't make them yourself. but are there any particular antenna technologies you see out there that are very interesting in terms of materials for certain use cases, rather than just being kind of what someone might just easily recognize as an antenna?
Yep. There are many new technologies coming, and even though we are not manufacturing, we are developing for many different manufacturing technologies, and therefore we need to know about them and be very much collaborating with the manufacturer anyway. I would say the stamp metal antenna was something that rather recently became rather popular. And then there are some new technologies that have been coming out within, let's say, a couple of years, like transparent antennas that have few use cases, a lot of interest. Let's see how it goes commercially. Then 3D printing of actual metal instead of just printing on surfaces, that can open up a lot of new opportunities in the future, because you can create like fully metallic, fully 3D structures without any kind of, well, some limitations of course, but very few. And then let's see what textile antennas, for example, enable in the future. So there are a lot of stuff happening on the manufacturing front as well, and we do our best to keep up with all of them so that we can then provide the consultancy to our customers to select the best one for them.
Nice. So I think we've covered quite a lot, and this has been very, very interesting, especially the kind of the talk of the automotive antennas, because I just don't get to talk about that very often. If an engineer was looking to build a device and they needed a custom antenna solution from Radiantum, what's the process by which they go through the development? Like, how does it? Can you take me through the journey that they'd expect to see?
Yeah. So let's say there's typically two kind of starting points. One where there is already hardware that exists, and then it is noticed that, hey, actually there's a problem. The performance is not good enough, or it could be even really serious situation, either from antenna or EMC perspective. So then the engineer can reach out to us. We will together evaluate the situation, that, okay, what is actually needed to dig in deeper. And then we work on consultation, let's say methodology. So we agree certain tasks to be done, certain amount of, for example, hours that we would then work for them, and help them out, help them get forward, and then they can continue the development on their own. Or if it turns out to be the situation where the customer already sees that, okay, hey, we had this hardware, but we need a custom solution, we can just measure the situation as a starting point and then create a new solution there on top of it. But that's not the optimal case. In best situation,
I thought you were going to say that.
Yeah. So the best situation is where the hardware engineer or someone else, project manager, for example, on our customer side, identifies early on that, hey, this product will need a custom solution. So the off-the-shelf are likely not going to work enough. So then they can reach out to us in early stages without anything ready, just to get us into the loop. We make contracts on how we support them, what is our role, what is their role in the development, kind of put those in place and then move according to the plan. So we are essentially integrated into the development team as an external experts to help them out in whichever challenge there comes in the development, including then the antenna design and EMC, EMI topics.
Cool. I knew you were going to say that you prefer it when people come to you at the beginning, because we've spoken to so many people, like battery companies or energy harvesting companies, and they're always like, we wish we were at the start of the design, because then we can tell you where you will go wrong before you do.
Yeah,
cool.
Exactly.
So I guess what's the best way for them, for engineers to get started with Radiantum in terms of contact?
So on our website, there is contact details. You can reach out to us through there. So that's the easy part. Of course, if you find me, for example, on LinkedIn, feel free to reach out. That's also a possibility. So yeah, whichever way. We do go to exhibitions as well. So that's one way to get in contact, and we can also then have already a chat on the actual application there.
Nice. And just for obviously people are going to watch this like near its release and afterwards. So what are some of the typical exhibitions that people can expect to see you guys at?
Yeah. In Germany, for example, Embedded World and Electronica are the big ones where we go with a stand. But then on top of that, we visit quite many other events, and we try to get information out about them in advance, so that if someone listening happens to be there, then they can reach out to us, and we can fix a place where to meet.
Nice. I think that's a great way to end. So thank you very much, Mikko, for this interview. It's been really fun. And there's kind of a joke in the office that I really, really like talking about antennas even more than semiconductors, which is kind of half true. I do talk about antennas a lot because I love mechanical design as well as electronics. Anyone who's looking for a custom antenna solution, Radiantum has vast experience across tons of applications. So go check them out. And again, Mikko, thank you so much for joining us.
Thank you. It was a pleasure.
Where my engineers at?